Imagine paying over 140 US dollars for a video game today. You walk into a store or, you log on to a digital storefront and you just drop $140 on a single title.
Right, which is just an absurd amount of money for a base game now.
It is. And the absolute cutting-edge, mind-blowing premium feature you are paying that massive premium for. The ability to save a 5-second video replay of your character jumping over a hurdle.
And I should point out, not just save it anywhere, you have to save it to a physical magnetic disk that is, frankly, highly susceptible to dust or magnets or even just like the ambient humidity in the room.
Right. If you tried to sell that to a gamer today,
Yeah.
they would literally laugh you out of the room. I mean, it sounds like an absolute scam. But, we aren't talking about today. We are dialing the clock way back to November 1984.
Yeah, 1984.
And in 1984, that wasn't a scam. That was the absolute bleeding edge of consumer technology.
It really was. It was a landscape defined by towering, almost incomprehensible technical limitations. I mean, we look back at early 1980s computing and game design, and it honestly looks like an alien world compared to the frictionless, high-fidelity theme park rides that modern games provide us.
Exactly. Modern game design is completely obsessed with comfort. You boot up a new release, and there's a beautifully voiced motion capture tutorial that just gently holds your hand for the first 2 hours.
Yeah, they don't want you to quit in the first 5 minutes.
Right. If you get lost, a glowing gold path appears on the ground to tell you exactly where to walk. If you fail a jump, you just instantly respawn with zero penalty. The entire architecture of the software is built to ensure you never feel frustrated, you never feel lost, and you never stop moving forward.
The modern user interface does all the heavy lifting, basically. It actively hides the mechanics running under the hood so you, the player, can just passively consume the world. But the sources we are looking at today represent the exact opposite philosophy.
Let's actually lay out those sources for a moment because we have an incredible stack of material to go through for this deep dive. We are unpacking a collection of contemporary 1984 reviews straight from the games section of the classic Personal Computer World magazine.
A legendary publication.
Truly. We're looking at deep, granular, and sometimes incredibly frustrated contemporary takes on everything from deeply complex naval simulators to bizarre arcade titles. And to anchor all of this, we're using a modern retrospective blueprint that tracks the inflation data from 1984 right up to our current year.
Because the money context is huge here. This is a highly analytical look at what I like to call design by deprivation. We are talking about an era where a computer's total accessible memory was measured in kilobytes.
Just kilobytes.
Yeah, a kilobyte is a fraction of a megabyte. To put that into a perspective that makes sense today, 64 kilobytes of memory is roughly the data size of a single low-resolution thumbnail image on a modern website. Just, the tiny picture of a shoe on a shopping site.
Wait, hold on. You're saying the entire game, like the graphics, the artificial intelligence, the rules, the sound effects, the player input, all of that had to fit inside the digital footprint of a tiny website thumbnail?
Less than that, in some cases. Which meant developers had absolutely no room for high-resolution graphics, no space for massive orchestral audio files, and definitely zero memory left over for helpful, complex user interfaces.
Right. They just couldn't fit it.
Exactly. They had to rely on bizarre creativity to bypass those limits. But more importantly, those severe limits forced the player to use their own imagination to fill in the massive gaps left by the hardware.
The friction wasn't a bug, basically. It was the entire foundation of the experience. Okay, let's unpack this. I want to jump right into a genre that pushed both the machines and the human beings playing them to their absolute breaking point.
Oh, the strategy games.
Yes, we are looking at the brutal high seas of 8-bit strategy, specifically 2 distinct naval strategy titles from this 1984 review stack. We have Midway on the Commodore 64 and Bismarck on the BBC Micro.
It is definitely worth contextualizing those two pieces of hardware before we dive into the games because the machines themselves completely dictated the design.
Right, the hardware was destiny.
Exactly. The Commodore 64 was becoming the absolute powerhouse of home entertainment. It had dedicated chips for sound and graphics, making it relatively friendly for gaming. The BBC Micro, on the other hand, was an entirely different beast.
The BBC Micro was the one built specifically for British schools,
Yeah.
right? Like it was a mandated educational tool.
Precisely. It was commissioned by the British Broadcasting Corporation. Its architecture was incredibly rigid, focused almost entirely on teaching programming, mathematics, and science.
So not a gaming machine.
Not natively, no.
Yeah.
It wasn't designed to be a smooth, scrolling arcade machine. It was designed to process logic. And the games developed for it heavily reflected that stark mathematical environment.
Which perfectly sets the stage for how wildly different these two naval games play. Let's look at Midway first. So this is running on the Commodore 64. You are commanding the American forces, trying to defend your aircraft carriers, while simultaneously hunting down and attacking the Japanese fleet.
A classic historical setup.
Right, but it's the mechanics of how you execute this that are so striking. You don't just, drag a box over your units and click on the enemy like in a modern real-time strategy game. You have to actively juggle squadrons.
The November 1984 review emphasizes this heavily. The reviewer points out that each aircraft carrier in the game can only handle one single squadron at a time.
That sounds like an absolute nightmare.
It is a brilliant piece of mechanical design born from historical realism, but implemented in a way that just maximizes player stress. I mean, let's break down the mechanics of a single engagement in Midway.
Yeah, walk me through it.
You start entirely blind. You don't know where the enemy is on the map, so you have to launch reconnaissance squadrons to find them. You send them out, and while they are searching the grid, you obviously want to start prepping your offensive bomber squadrons on your other carriers.
You have the bottleneck.
Yeah.
One squadron per carrier deck.
Exactly. So you're engaged in this terrifying logistical puzzle. You have planes that need to launch to go attack, but you also have those reconnaissance planes returning from their patrols that desperately need refueling and rearming.
Oh, man.
Right, and if your deck is busy prepping the bombers, the returning recon planes just have to circle the carrier. They are actively burning fuel. If you don't clear the deck in time, they just crash into the ocean. You are essentially managing an air traffic control queue in the middle of a war zone.
And you are doing all of this through a super rudimentary interface. You have a basic map display, and you are moving a cursor around with a stiff 1980s joystick. The review notes that the time it takes for a unit to get somewhere actually depends on the unit type.
Nothing is instantaneous.
Right. You tell a plane to go somewhere, and you just have to sit there and wait and watch the little icon slowly crawl across the screen.
And that pacing is where Midway really turns the psychological screws. The game doesn't just wait for you to make your moves. There is a real-time clock ticking away at the top of the screen. The reviewer specifically warns players to watch this clock carefully because it dictates the oncoming night cycle.
This night cycle mechanic sounds genuinely panic-inducing. When night falls in Midway, all of your aircraft are grounded. You literally cannot launch planes in the dark. But, and this is the brutal part, the Japanese fleet does not stop.
They just keep coming.
They continue to move under the cover of darkness.
Think about the psychological weight of that for a second. In a modern game, a day-night cycle is almost entirely aesthetic. The sun goes down, the lighting engine shifts to moonlight, maybe some different enemy types spawn in the forest or whatever.
Yeah, but you can still see everything.
Right, you still have your heads-up display. You still have your mini-map in the corner. You still have your glowing objective markers. In 1984's Midway, nightfall means total, suffocating blindness.
You literally have to just sit there, defenseless from the air, knowing the board is changing without your input. You spend all day carefully positioning your fleet based on the last known trajectory of the enemy. Then the sun goes down, you lose your eyes in the sky, and you just know they are moving closer in the dark.
The immersion isn't coming from the graphics at all. It's coming entirely from the vulnerability. The reviewer notes that you have to find them quickly the next morning or, quote, they'll catch you unawares.
Which is very polite British magazine speak.
Exactly. Polite 1984 British magazine speak for they will obliterate your entire fleet while you are fumbling with your joystick. It creates a frantic, desperate rhythm. It's just logistical juggling during the day, followed by agonizing, helpless waiting during the night.
And the information you get is so asymmetrical, too. You receive detailed text reports on your own units, right? Like how much fuel they have, whether they've dropped their bombs. But for the enemy, if your search aircraft is actually tracking a fleet, the review says you only get a, quote, cloud-covered view of them.
This is such a fascinating use of limited graphics. The game doesn't just give you a text prompt saying 3 destroyers and a carrier. It renders a pixelated, static image covered in digital clouds, and you, the human being, actually have to peer through the smudgy pixels on your CRT television to try and identify the silhouettes of the ships.
You have to interpret it yourself.
Yes, it demands your active visual interpretation.
Which brings up, honestly, the most bizarre mechanic in this entire review. When you finally commit to an attack, the game completely shifts genres. It drops the high-level map strategy, switches to an arcade perspective, and you suddenly have a crosshair. You have to physically shoot down attacking planes with your joystick.
It's totally jarring.
It is. But the reviewer casually mentions a specific feature the developers included. You can, quote, even shoot at your own planes.
Friendly fire as a dedicated, programmed feature.
Right. And the reason the magazine gives for this feature, quote, for the arcade players who can't resist shooting at anything that moves on the screen.
That is just such a revealing piece of historical text. It shows that developers in 1984 acutely understood the demographic divide in their audience. They knew this naval simulation was slow, it was demanding, and it required immense patience.
Yeah, sitting around waiting for a tiny dot to move.
Exactly. They understood the mental fatigue of waiting for virtual planes to refuel, so they intentionally programmed in a mechanic where bored players could literally blow up their own digital investments just for a quick hit of arcade dopamine.
Like, I've been waiting 4 minutes for this recon plane to land. I'm just going to shoot it at the sky. It's hilarious, but it perfectly illustrates how demanding these strategy games were on a player's attention span. Which makes me want to look at the other side of this naval coin, which is Bismarck on the BBC Micro. Because if Midway is about real-time panic and queue management, Bismarck is pure mathematical dread.
Mathematical dread is a very apt description, and it stems directly from the hardware we discussed earlier. The BBC Micro was a machine built for logic, and Bismarck leverages that to create a game that is essentially a deeply complex, digitized search theory problem. It strips away the real-time clock entirely and replaces it with a rigid, unforgiving, turn-based structure.
You are playing the British forces, and your singular goal is to find and destroy the German battleship Bismarck. The review makes the stakes immediately clear from the start. The Bismarck is faster than any of your ships and is more powerful than any of your ships. You are completely outgunned and outrun from turn one.
And you don't have unlimited time to slowly comb the ocean either. You are operating on a massive battleship-style grid system, and the game gives you exactly 13 turns.
Just 13.
That is the hard limit. 13 moves to search the entire North Atlantic, locate the most dangerous warship in the world, and coordinate enough firepower to actually sink it before it escapes.
So wait, how do you even approach that? Because if the grid is massive and you only have 13 turns, you clearly have to spread your ships out, right? Like casting a wide net to cover as much ocean as possible.
I mean, that is the instinct, yes. But the reviewer perfectly captures the core dilemma of the game's resource tension. If you spread your ships out into a massive thin net to maximize your search probability, what happens when one of those isolated ships actually finds the Bismarck?
Oh, right. You just said the Bismarck is more powerful than any single ship. So the lone ship that finds it just gets instantly obliterated.
Exactly. The Bismarck destroys your scouting vessel, changes course, and now you have a gaping hole in your search net. But if you do the opposite, if you keep your fleet tightly clustered together in an unstoppable armada so you actually have the firepower to win an engagement, you are only searching one tiny square of the ocean per turn.
You'll never find it.
Right. With only 13 turns, the Bismarck will easily slip right past your concentrated forces.
You are constantly agonizing over that balance. Spread out and risk getting picked off one by one, or group up and risk never finding the target at all. And just to make it even more punishing, the game layers on a completely randomized weather mechanic.
The weather dictates your absolute most valuable asset, which is aircraft. The review mentions that if the weather is fine, you can order your carriers to launch search aircraft, which can scan a massive area of the grid in a single turn. It is your best tool for locating the target without risking your capital ships.
But you are only allowed to launch aircraft 4 times in the entire game. 4 times. You have 13 turns, and you only get 4 launches. And that is purely if the weather cooperates. You might hold on to a launch, waiting for the perfect strategic moment to deploy your planes, only to hit end turn and watch a digital storm roll in, grounding your entire air wing for the next 3 turns.
And the penalty for failing to balance this math is stark. At the end of the 13 turns, the game evaluates your performance and awards you a points total, up to a maximum of 100. The reviewer in the magazine openly admits that on their first, quote, feeble attempt, they achieved the spectacular score of -30.
Negative 30 points. The game didn't just tell you that you lost. It calculated your performance and decided you were actively a detriment to the war effort. You literally owe the game points.
What's fascinating about both Bismarck and Midway is how they exerted this immense cognitive pressure entirely without the safety nets of modern user interfaces. I mean, we take so much for granted today. When you play a strategy game now, you have a mini map in the corner giving you a god's eye view of everything we've discovered.
Oh yeah, fog of war gets lifted, you see everything.
You have auto-pause mechanics that freeze the game the millisecond an enemy is spotted, giving you infinite time to formulate a response. You have overlay radiuses showing exactly how far a ship can move or shoot.
They had absolutely none of that. You had text readouts detailing coordinates, you had rudimentary, chunky graphics that barely conveyed what you were looking at, and you had your own memory. Playing these games sounds like trying to play a high-stakes game of chess, but you are completely blindfolded, and someone across the room is just randomly shouting out the time while moving your pieces.
The mental visualization required was truly staggering. You had to hold the entire state of the board in your mind.
But let me challenge you on that, because we tend to romanticize this older era a lot. Was that lack of interface actually good design? Or was it just a sheer hardware limitation disguised as a feature? Like, did the total lack of visual feedback actually make the games more terrifying and immersive? Or was it just clunky and frustrating? Because I have to imagine that staring at a static grid on a BBC Micro, trying to calculate probabilities in your head, doesn't feel like commanding a fleet. It feels like doing homework.
That is a very fair critique, and it is essentially the central debate of retro computing. Was the friction a limitation or an aesthetic? To answer that, we have to look at how the human brain processes incomplete information. When a modern game renders a photorealistic 3D model of a battleship bearing down on you, complete with dynamic water physics and booming spatial audio, it is a passive experience for your imagination. You simply consume the image exactly as the developers built it. The terror is entirely external.
Right, the screen does all the work for you.
Yes. But when Bismarck presents you with a stark text box that says, weather is bad, turn 12, sighting in grid H4, and you know you only have one turn left and your forces are entirely out of position, your brain aggressively constructs that reality. You picture the freezing rain, the gray waves, the absolute panic on the bridge of your ship.
Your mind fills in the blanks.
Exactly. The monster your brain builds in the dark is always more terrifying than the pixels the hardware can render. The friction of the mechanics, the pressure of that 13-turn limit, the ticking clock of the night cycle in Midway, these aren't just rules, they are atmospheric tools.
It's the difference between reading a really tense, slow-burn thriller novel and watching a loud, explosive action movie. The novel requires your active cognitive participation to build the world. But man, the mental load of building that world in your head while simultaneously trying to manage an air traffic control queue and do probability math so you don't get a score of -30, I mean, that must have been utterly exhausting.
It absolutely was. The mental fatigue of managing 8-bit naval fleets was a very real phenomenon. And if we zoom out to look at the broader context of the 1984 games market, this heavy cognitive load perfectly explains the larger ecosystem. It explains why, alongside these hyper-complex simulators, there was an insatiable market for completely different reflex-driven arcade games.
Right. Here's where it gets really interesting. Because sometimes you just don't have the mental bandwidth to calculate grid coordinates for 13 agonizing turns. If you've been at school or work all day, your brain is totally fried, and you just want to boot up something fast, loud, and immediate.
The strategy simulators demanded everything from your intellect and memory. The arcade titles demanded everything from your central nervous system and physical reflexes. Which brings us to the next massive category in our review stack: the arcade translations.
Let's pivot from the freezing math-heavy waters of the North Atlantic to the chaotic city centers of, well, wherever the game traffic is set.
Traffic for the Commodore 64. The premise of this game is a brilliant distillation of the arcade philosophy. It's incredibly simple to understand, yet almost impossibly difficult to master.
The review explicitly states that old maxim, simple ideas are often the best. Your task in this game is just to control sets of traffic lights at city center junctions. Your one and only goal is to keep the traffic moving and prevent jams. If you cause a jam, the review says you, quote, get the sack and the game ends. If you succeed, you get promoted to a harder, busier part of the city.
What stands out immediately in the review of Traffic is the description of its visual presentation. The reviewer notes that the graphics are smooth and simple, and specifically describes the cars on the screen as little more than, quote, blobs moving down the streets.
Wait, blobs? This is the Commodore 64. We just talked about how it was a graphical powerhouse with dedicated chips. It could render decent sprites. Why are they just driving colored blobs around? Was the developer just lazy? I can't imagine drawing a tiny rectangle with two black dots for wheels. Is that hard to program?
It wasn't laziness at all, actually. It was an extreme performance optimization, and this requires a quick dive into how these processors actually work. The CPU of a Commodore 64 runs at roughly 1 megahertz.
1 megahertz.
That's right. That is incredibly slow by modern standards. Our modern phones run billions of cycles per second. The Commodore 64 ran 1 million.
Okay, but a tiny car sprite doesn't take a million cycles to draw, does it?
Not to draw once, no. But an arcade game relies on high frame rates. To create the illusion of smooth motion, the computer has to erase the car, calculate its new position, and redraw the car dozens of times every single second. Every single pixel you draw requires computational logic. If you try to draw a beautifully detailed, multicolored car with spinning wheels and exhaust fumes, the processor has to do math for every single pixel of that detail, every single frame.
And if there are 20 cars on the screen approaching a busy intersection?
The processor simply cannot update the screen fast enough before the television's cathode ray tube tries to draw the next frame. The game will chug, the frame rate will drop to a sluggish crawl, and the fast-paced twitch reaction gameplay is completely ruined.
I see. So the blobs were a conscious trade-off.
Exactly. To get the speed required for an arcade experience, you have to sacrifice graphical fidelity. You reduce the car to a single-color blob because drawing a solid block of pixels takes a fraction of the processing power of drawing a detailed sprite. The developer makes a deliberate aesthetic sacrifice. They're basically saying, I will give you an ugly game, but I will give you a fast game. In an arcade title, speed and responsiveness are the only metrics that actually matter.
That is fascinating, because it's the exact inverse of modern game development. Today, studios will regularly cap a game's frame rate, forcing it to run at a sluggish 30 frames per second, just so they can squeeze in more graphical effects, ray-traced lighting, volumetric fog, individual strands of hair on a character model. In 1984, they gladly burned the graphics to the ground, reducing the world to colored squares, just to keep the game running at a blistering speed.
And that speed was necessary because traffic requires split-second reactions. You aren't planning minutes ahead like in Midway. You are watching a dozen colored blobs converge on a junction from 4 different directions, and you have to flip the lights with perfect timing to interleave the traffic. It is pure, unadulterated Twitch gaming.
I really love the little aside the reviewer makes about the game's premise, too. They note that the game was quite a revelation for them, stating, quote, I've always thought that a traffic controller's job was to kind chaos, not avoid it.
Right. Anyone who has sat in rush hour traffic can deeply relate to the reviewer's cynicism there. But that Twitch gaming aesthetic, that demand for pure reflex over logic, is cranked up to an absolute fever pitch in another review from this issue. Storm Warrior, also for the Commodore 64.
This one is wild. Storm Warrior is described as a multi-screen arcade game.
Multi-screen is another critical hardware workaround. Instead of the camera smoothly scrolling continuously across a massive landscape, which again requires immense processing power because the CPU has to redraw the entire screen's background every single frame, a multi-screen game operates like a slideshow. You complete the challenge on one static screen, the screen goes black for a split second, and the game instantly loads a completely different static background and a new set of enemies.
And the context switching between these screens in Storm Warrior is giving me whiplash just reading the descriptions. The narrative consistency is zero. It is purely about throwing new mechanical challenges at your reflexes. The review describes the very first screen. You are involved in a, quote, deadly ball game with an evil-looking gremlin who's throwing a fireball at you.
The mechanics are beautifully distilled. The gremlin throws a fireball. If it hits you, you die. You have a sword, and you have to deflect the fireball using logical joystick movements. If you manage to parry the fireball back past the gremlin, you win the screen. It is essentially an ultra-violent, fantasy-themed version of Pong.
But the moment you survive that duel, you don't get to rest. The game immediately throws you into a totally different genre. The screen flips, and now you have to prevent deadly birds from swooping down and carrying you away. You beat that, the screen flips again, and you are suddenly thrust into a duel with, quote, equally deadly scorpions and men. And this absolute fever dream culminates in what the reviewer describes as a particularly graphic struggle on a carpet as you travel towards a lightning-lit island.
A graphic struggle with scorpions on a magic carpet heading toward a lightning island.
I mean, the sheer imaginative whiplash is incredible. You go from deflecting a fireball with a sword to fighting birds to wrestling scorpions on a carpet in midair. There's no attempt at a coherent story whatsoever. There is only the escalating demand for faster and faster physical reflexes. But here is the absolute best part of the Storm Warrior review. The piece of trivia tucked at the very end that completely blew my mind.
The programming credit.
Yes. The review casually mentions, quote, Storm Warrior was written by a ballroom dancing teacher, but it certainly isn't a waltz.
It is a stunning piece of historical context that perfectly encapsulates the Wild West nature of early 1980s software development. I mean, the barriers to entry for the industry were completely different than they are today. Today, game development requires massive teams of specialized artists, riggers, engine programmers, and producers.
It's a huge operation.
Right. But in 1984, if you had the patience to sit down with a manual and learn basic or assembly language, your real-world professions simply did not matter. You could be a ballroom dancing instructor who goes home at night, stares at a CRT monitor, and codes a multi-screen game about parrying fireballs from gremlins.
But when you think about it, it actually makes a weird kind of sense. What is ballroom dancing? It's all about precise timing, rhythm, and spatial awareness. You have to know exactly where your partner is, anticipate their movements, and move in sync without stepping on their toes. What is a fast-paced arcade game if not a digital dance? Your partner is just an evil gremlin trying to kill you. It requires the exact same physical coordination and understanding of rhythm. It's just being translated through the micro switches of a joystick instead of your feet.
That is a wonderful connection to make. It is the choreography of code. The developer intuitively understood timing and spatial pressure and translated that directly into a brutal arcade experience.
But if rendering colored blobs and static backgrounds was pushing these 1 megahertz processors to their absolute limits just to maintain a playable speed, it raises a massive question about the next batch of games in our stack. If you barely have enough memory and speed to draw a car, how on earth did developers attempt to simulate artificial intelligence and complex narrative storytelling?
That is the perfect question to ask because it leads us directly from the reflex-driven arcade into the absolute bleeding edge of 1984 AI and interface design. We have to examine a game that sounds simultaneously incredibly ambitious and completely infuriating to actually play, Sherlock for the 48KZX Spectrum.
Supplied by Melbourne House, who were a legendary publisher of text adventures during this era. Now, for those who might not know, what exactly was the 48K Spectrum?
The Sinclair ZX Spectrum was an absolute phenomenon in the UK. It was incredibly cheap compared to the Commodore 64, famously featuring a keyboard made of squishy rubber keys. As the name implies, it had 48 kilobytes of RAM. That is the entirety of your workspace to build a living world. And yet, Sherlock attempts to do things on this tiny machine that modern games with gigabytes of memory still struggle with.
It's a text-based adventure game, so no graphics, just reading and typing. The review sets the scene. Quote, this is your chance to be the world's greatest detective as you attempt to solve a crime that has Scotland Yard baffled. The game starts in your lodgings at 221B Baker Street with Dr. Watson. Standard text adventure stuff so far. But then the review drops this massive bombshell for 1984. Quote, the time is 8 a.m. and the next move is yours. The time is important as the characters move in real time. In other words, if you don't get to the scene of the crime in time to do some detecting, Inspector Lestrade will arrest the wrong man and the game will be over.
We really need to dissect the mechanics of that because it is groundbreaking. In almost every other text adventure of this era like Zork or The Hobbit, the world is entirely static. Time does not exist until the player types a command and hits enter. You could walk away from your keyboard, go on vacation for 2 weeks, come back, and the digital goblin would still be standing in the exact same room waiting for you to swing your sword.
The world pauses for you.
Yes, the game state was entirely dependent on player input. Sherlock completely shatters that safety net.
It has an independent clock running in the background.
Right.
The world is moving without you.
Yes, you are literally racing against the incompetence of the digital police force. If you dawdle at Baker Street trying to figure out how to open a drawer, or if you take too long interviewing a suspect, the AI controlling Inspector Lestrade just goes ahead, arrests some poor innocent bystander, and gives you a sudden game over.
That is immense pressure. And the innovation doesn't stop with a real-time clock. The reviewer points out that the game's most impressive feature is the conversational AI. The ability to, quote, talk to the characters and discuss and argue the case with Watson and Inspector Lestrade. The reviewer provides this amazing anecdote, quote, I tried to delay the good inspector by confidently announcing the identity of the murderer, only to hear that he didn't believe me. To make matters worse, the inspector then demanded the required evidence and finally ignored me.
It is brilliant. You can't game the system by just randomly guessing the murderer's name to see what happens. You try to bluff the AI, and the AI essentially says, "Pics or it didn't happen, Sherlock," demands physical proof from your inventory, and when you can't produce it, it dynamically shifts its state to ignore you.
I am genuinely baffled as to how they achieved that on a 48 kilobyte machine.
Huh.
How do you program a branching argument where an NPC demands evidence and judges your inventory when you barely have enough memory to store a few pages of text?
It was done through incredibly clever parser design. The game didn't actually, understand English. It used a rudimentary dictionary of nouns and verbs. When you typed a complex sentence like, "Tell me about the bloody knife found in the parlor," the game discarded most of the words. It scanned specifically for the hex code linked to the verb tell and the noun knife. It then checked a tiny logic flag. Does the player have the knife in their inventory? If yes, print text string A. If no, print text string B, which is Lestrade ignoring you. It is an illusion of intelligence, but implemented with such strict logic that it genuinely felt like arguing with a real stubborn person.
But the ambition of creating that illusion came with an incredibly heavy cost when it came to the user interface, because this game sounds actively hostile to navigate.
Oh, the friction is immense.
The review notes that Holmes doesn't like walking, so you have to use cabs and trains to get around London. But here's the catch. You don't just pull up a map and click an icon. There is no map. The review explicitly states no map is provided. And the cabbies only respond to specific street names. So if you want to go investigate the train station, you cannot type, "Go to King's Cross Station."
If you type that, the purser won't recognize it, and the cabbie will just stare at you.
Right. You have to possess or acquire external knowledge of Victorian London's street layout. You have to know the actual geography and type. Ask for King's Crossroad.
You are required to use a physical, real-world street directory just to navigate the game's basic fast travel system.
That is the ultimate sink-or-swim interface. The game throws you onto the streets of London and basically says, "Good luck, buy a map." And once you finally arrive at your destination, the interface for interrogating suspects is just as rigid. The reviewer notes that you have to use exact command sequences like, "Tell me about." You are blindly typing phrases, hoping you hit the exact noun-verb combination the parser recognizes.
What's fascinating here is that this hostility wasn't poor design. It wasn't an accident caused by lazy programming. It was an ambitious, deliberate attempt to replicate the genuine bureaucratic frustrations of detective work. Real detectives in Victorian London didn't have glowing waypoint markers hovering over a suspect's head. They didn't have dialogue trees with 3 neat options to choose from.
They had to figure it out themselves.
Exactly. They had to know the geography of the city, they had to ask precisely the right questions, and they had to deal with uncooperative, stubborn people. The interface friction wasn't in the way of the gameplay. The friction was the gameplay.
We see a very similar ambition and similar friction in another game reviewed here. Avalon for the 48K Spectrum. The premise is epic. You play as Maroc the Mage, trying to stop the forces of evil in the crumbling remains of the Roman Empire. But what is staggering is the graphical ambition. On this tiny rubber-keyed machine with 48 kilobytes of memory, the developer attempted to display the dungeon rooms in 3D isometric graphics.
This is a huge leap from text adventures or flat top-down grids.
How do you even do 3D on a machine that has no graphics card?
By using complex isometric math, they aren't rendering actual 3D polygons. They are drawing 2D sprites, but plotting them on a diamond-shaped grid to trick the human eye into perceiving depth. But plotting depth requires sorting algorithms. The computer has to constantly calculate which object is in front of which other object, which is known as the painter's algorithm, so it draws the goblin in front of the wall and not behind it. Doing that math on a 1 megahertz processor is incredibly taxing.
And it seems the hardware really struggled under that weight, because the reviewer notes that the graphics, quote, smudge quite badly, though they hoped it was just an issue with the pre-production version they were given.
That smudging is a legendary flaw of the ZX Spectrum called attribute clash, or color clash. The Spectrum couldn't assign a unique color to every single pixel. To save memory, it divided the screen into 8 by 8 pixel blocks, and each block could only contain 2 colors. When an isometric 3D character walked in front of a background object within that same 8 by 8 block, the hardware couldn't handle the conflicting color data, so the colors would bleed into each other, creating that smudged, glitchy look. It was the absolute limit of what the machine could render without crashing.
But the developer pushed through that glitchy hardware to implement a truly wild mechanic. In Avalon, you have spells with limited life, and you are constantly being drained of energy by the nasties in the lair. But the reviewer highlights a specific group of spells called cursor spells. There is a spell called Servant that literally gives you control of a sprite, a little cursor that you can detach from your character and move around the screen independently to open doors and collect objects.
A cursor spell. You are casting a magical spell to summon a basic user interface element. It's incredibly meta. The developer couldn't just give you a mouse cursor, so they integrated it into the fiction of the magic system.
But the reviewer warns that this is a skill you have to practice because, quote, it's difficult finding room away from the evil goblins, guardians, wraiths, and wizards to safely use this cursor. Think about what this demands of the player. You are in a smudgy, glitchy 3D room. Your main character is actively being mauled by wraiths. And to escape, you have to cast a spell, detach your controls from your body, and micromanage this tiny little sprite cursor across the room to click on a door to open it.
It is another prime example of incredible mechanical ambition leading to extreme cognitive overload. The developer is giving you a novel, groundbreaking tool, but making the very act of using that tool inherently dangerous and stressful.
All of this friction-like, the aggressive AI in Sherlock that demands perfect syntax, the lack of a fast travel map, the micromanagement of a cursor while being attacked in Avalon, it really makes me wonder about how we play today. Think about the modern open-world games we play now. We have glowing waypoint markers that tell us exactly where the murderer is hiding. We have instant fast travel menus where we just open a map, click an icon, and teleport across the continent.
We barely even look at the world, we just look at the mini-map.
Exactly. We have quest logs that perfectly summarize everything we need to do so we don't have to remember anything. Is it possible that these modern conveniences have actually robbed us of something profound? Have we lost the deep intrinsic satisfaction that came from having to physically draw out the map of Victorian London on a piece of graphing paper on your desk?
That is the crux of the retro gaming argument, and it's a powerful one. When a game provides an interactive, perfect, accurate map, navigation ceases to be a challenge. It becomes a trivial task. You just point your character at the icon and follow the line on the ground. When a game does not provide a map, navigation becomes an adventure. You are forced to deeply engage with the spatial reality of the digital world. You have to draw it, you have to remember landmarks, you have to conquer the layout.
The friction creates the memory.
Precisely. How many massive, beautiful, modern game worlds have you mindlessly fast-traveled through, checking off icons, only to immediately forget the layout the moment you put the controller down? Contrast that with a player in 1984 who spent 3 weeks drawing their own physical map of the 223 rooms in Avalon's dungeon. They will remember that layout for the rest of their lives because they built it themselves. The frustration is the crucible where the satisfaction is forged.
You don't feel like a genius when a glowing arrow leads you directly to the murderer. You feel like a genius when you correctly deduce the exact noun-verb syntax needed to make Dr. Watson hand over the magnifying glass so you can find the clue yourself.
But there is another massive factor we have to consider when discussing the deep, obsessive engagement players had with these games. It wasn't just the mechanical friction that kept them drawing maps and fighting through the frustration. It was the financial friction.
Oh, wow. Yes. The economics of play. We have been exploring the incredible ingenuity, the hardware workarounds, and the brutal difficulty of these games. But we need to zoom out and look at the bigger picture of what it meant to be a gamer in 1984. To access this bleeding-edge technology to play a game with branching AI or 3D graphics, what was the actual financial toll on the player?
To truly understand this, we have to look at the absolute premium showpiece of this magazine's review section. We need to talk about Hesgames for the Commodore 64.
The review title for this one is Move Over, Daley, which is a direct reference to the massive arcade hit Daley Thompson's Decathlon. Hesgames is a collection of 6 Olympic-style sporting events. You've got the 100-meter sprint, the 110-meter hurdles, long jump, diving, archery, and weightlifting. And from the very first paragraph, this game is positioned as an absolute top-tier premium product.
The review goes into great detail about the features that justified its status. The very first barrier to entry, it required a disk drive.
Let's explain why that is a big deal. Why was a disk drive a luxury? Weren't floppy disks just standard?
Not in 1984 home computing. The vast majority of consumers were loading games off standard audio cassette tapes. The exact same tapes you'd use to listen to music. You'd put a game tape in a cassette deck, press play, and the computer would translate the screeching audio pulses into code. It was an agonizingly slow, sequential process. You couldn't skip to level 2, you had to fast forward the physical tape, and if there was a single speck of dust on the magnetic ribbon or a slight fluctuation in volume, the load would fail after 5 minutes and you'd have to start completely over.
So a floppy disk drive.
Was a revelation. A disk drive offers random access. The read head can instantly jump to any part of the disk to pull data. It was infinitely faster, more reliable, and a massive luxury peripheral that cost almost as much as the computer itself. And Hesgames required one.
And it used that disk drive for a groundbreaking feature. At the touch of a button, you could watch an action replay of any shot, race, dive, or lift you just performed. And if you beat a world record, you could literally save that replay attempt to the floppy disk to, as the review says, be recalled whenever you want to amaze your friends.
Saving a video replay to a physical disk to show off later. In 1984, that level of persistent data storage was practically science fiction. Now, to be clear, it wasn't saving a massive video file. It was saving the sequence of your joystick inputs and then recreating the physics simulation on playback. But to the player, it was magic.
Furthermore, the gameplay itself was elevated far beyond the standard sports games of the time. Unlike Decathlon, which famously required players to just aggressively waggle the joystick left and right as fast as possible to run, which literally snapped the plastic stems of thousands of joysticks across the country. Hesgames demanded finesse. The reviewer notes that in the diving event, quote, you have to call and execute forward and reverse dives as tidily as possible, landing straight in the water. It required perfectly timed, precise joystick movements.
And the ambient detail was incredibly dense. The review notes that each event is steeped in detail, which consumes a lot of memory. They give the specific example of the weightlifting event. The crowd watching you isn't just a static background painting, it's an AI-driven crowd. The review says they either applaud a good lift or turn and mutter to each other about a failed attempt.
The developer used their precious kilobytes of memory to program a virtual audience that actively gossips about your failure. It is amazing.
Yeah.
But all of this premium detail, the strict disk drive requirement, the ability to save replays, the judgmental AI crowd, it came with a staggering price tag.
And this is where we bring in our modern retrospective blueprint with the inflation data. We need to do the math on this because it contextualizes the entire era. The historical economic data shows that consumer prices from 1984 have multiplied by a factor of roughly 4.17 by our current year of 2026.
Let's lay out the baseline first so we have something to compare it to. Standard single-load budget games like our Colored Blob Simulator Traffic or the mathematical dread Bismarck were priced at £7.95 in November 1984.
If we multiply that by our 4.17 inflation factor, a basic game was the equivalent of £33.15 today. That is entirely reasonable. That aligns perfectly with the price of a modern indie game download.
Okay, what about the ambitious, multi-character, real-time AI of Sherlock? That was a step up. It was priced at £14.95.
Which equates to £62.34 in today's money. Basically, the standard entry price for a modern AAA release from a major studio.
Exactly, a full-priced release. But then we get to Hesgames, the premium floppy disk experience with a gossiping crowd. The price listed in the magazine for this collection of 6 minigames is £27.95. Multiply that by our inflation factor, and Hesgames cost the staggering equivalent of £116.55 in today's money.
Over £116, roughly $140 for a sports game that required you to already own an expensive disk drive.
And remember the context of digital versus physical goods at the time. The review section of this magazine also covers a game called Flight from the Dark, which is a digital adaptation of the famous Lone Wolf Choose Your Own Adventure books. The digital game costs £6.95. But the reviewer points out a fascinating discrepancy. You could walk into a bookstore and buy the physical paperback book that the game is entirely based on for only £1.50.
Let's do the inflation math on that. The physical book was the equivalent of £6.25 today. The digital version of the exact same story was nearly £30.
The premium you were paying just for the novelty of having a microchip handle the page turning and the dice rolling for you was astronomical.
If we connect this to the bigger picture, it completely recontextualizes how players interacted with these games. Gaming in 1984 was not a cheap, disposable, throwaway hobby. You didn't buy a bundle of games on a digital sale for $5, play them each for 20 minutes, get slightly confused by the controls, and uninstall them forever. Buying a game was a massive, highly considered financial investment for a household.
Think about the game you have sitting on your hard drive right now, the one you played for an hour and got bored of. Would you be willing to pay £116 today just for the privilege of playing it.
The sheer financial weight of that purchase permanently changes your psychological relationship with the software.
Absolutely.
Hmm.
If you begged your parents for Hesgames for your birthday, and they spent the equivalent of 116 pounds on it, you had to play it to death. You were going to sit there and master the precise joystick timing of that diving mechanic, no matter how frustrating it was. You were going to save every single replay you could. And, going back to Bismarck, if you spent over 30 pounds in today's money on a strategy game, and your very first attempt resulted in a humiliating, insulting score of -30, you didn't just walk away.
No, you couldn't afford to walk away.
Exactly.
Yeah.
You got out a pen, you got out a pad of graphing paper, you gritted your teeth, you played it again and again until you beat it.
The high price tag, combined with the severe difficulty and the complete lack of hand-holding interfaces, forged a gaming culture of deep, obsessive dedication. You had to extract every single ounce of value from the code because the code cost a fortune. It fostered a level of patience and perseverance that is almost entirely absent in mainstream gaming today, simply because the economic necessity to push through the frustration is gone. You conquered the friction because you paid for the friction.
It's the ultimate sunken cost fallacy, but it resulted in players truly mastering the limited mechanics they were given. They didn't just consume the game, they conquered the machine itself.
Beautifully put.
So what does this all mean? We have covered an incredible amount of ground today. We've traveled from the terrifying blind spots of a real-time naval clock in Midway to the paralyzing search theory math of a 13-turn limit in Bismarck. We've seen how the sheer mental exhaustion of that strategic thinking naturally led to the chaotic, simplistic blob dodging of traffic, where graphics were burned away for the sake of processor speed, and the surreal ballroom dancer choreographed multi-screen madness of Storm Warrior.
We observed how early attempts at artificial intelligence and 3D graphics in games like Sherlock and Avalon pushed the kilobyte limits of the hardware to their absolute breaking point. These games forced players to interact with digital worlds that were entirely hostile and unaccommodating to their presence, demanding exact syntax, real-world geographical knowledge, and spatial micromanagement, entirely without the safety net of modern maps for tutorials.
And we grounded all of that mechanical friction in the staggering economic reality of 1984. An era where a premium sports game with an AI crowd that muttered at your failures cost the modern equivalent of over 116 pounds, forcing a level of dedication and patience from the player that we can barely comprehend today. The severe limitations of 1980s hardware didn't just force developers to be creative, it forced them to lean into intense mechanical pressure to make the games worthwhile.
The hardware could not physically provide a comfortable, frictionless theme park ride, so the developers built an exhausting, complicated obstacle course instead. And the players, having paid handsomely for entry, gladly threw themselves at the walls until they broke through.
It has been a truly eye-opening journey back to the foundations of game design. But before we leave you, we want to offer one final, lingering thought to ponder long after this deep dive ends. We started by comparing modern gaming to that frictionless theme park ride. Today, developers have access to virtually unlimited memory. They have game engines capable of rendering photorealistic lighting in real time. They have procedural generation algorithms that can build entire, unique continents on the fly.
The kilobyte limitations of 1984 are long gone. The canvas is infinite.
But if unpacking these sources today taught us anything, is that severe limitations are often the ultimate catalyst for human creativity. The friction wasn't just a hurdle. The friction was the magic that sparked the player's imagination. So the question you have to ask yourself next time you boot up a game is this. In our relentless pursuit of the perfect, photorealistic, entirely frictionless experience, are our modern limitless game engines actually making our digital worlds less imaginative?